Hello again. Today we're going to be talking about Lhopitals Rule. Lhopitals Rule is going to be used whenever we're trying to find a limit where the limit is a fraction, but the numerator and denominator are both going to 0. Okay, so let's write this formally. So if we have a limit as x approaches a of f of x over g of x, where the limit as x approaches a of f of x equals 0, and the limit as x approaches a of g of x equals 0, then the limit as x approaches a of f of x over g of x is going to equal the limit as x approaches a of the derivative of f of x over the derivative of g of x. Okay, so Lhopitals rule is basically applying whenever you have 0 over 0, which we talked about this a little bit in the past when we were doing limit problems early on. And usually what I would explain to do is whenever you have 0 over 0, try factoring, or maybe using the conjugate if there's square roots somewhere in the equation. So you have to use some sort of simplification technique in order to rewrite it in a different way where it's no longer 0 over 0, which would be indeterminate. This is a new tool that we can use so that we can find limits of 0 over 0 cases where we cannot simplify by any other means. So let's look at a couple of examples. Okay, so let's say that we're doing a limit as x approaches 0 of 1 minus cosine of x over x. Okay, so there is no algebra technique that I could use to somehow simplify, factor, or cancel anything, or even trig identities. There's nothing really that would help too much. So, well, first of all, we should just plug in 0, see if it's not 0 over 0. Well, if you plug in 0, cosine of 0 is 1, 1 minus 1 is 0, so the top is 0, and then the bottom is also going to 0, so it is 0 over 0, which means that we don't know what it is yet. That's why I put the little question mark at the end there. So let's apply Lhopitals rule, because this is the 0 over 0 case. We should be able to use Lhopitals rule. Lhopitals rule says that this limit equals the limit as x approaches 0 of the derivative of the top over the derivative of the bottom. Note, we're not doing the quotient rule. Lhopitals rule is a rule for limits of quotients, but you're not taking the derivative and you're not using the quotient rule of the whole thing, just the top and bottom separately. Anyway, the derivative of the top is going to be 0 plus sine of x, because the derivative of cosine is negative sine and the two negatives cancel. The derivative of the bottom is 1. Now if you plug in 0, sine of 0 is 0, and you wind up with 0 over 1, which is 0. So the answer is 0. Okay, let's do another example. Okay, let's say that we have the limit as x approaches 1 of sine of pi x over ln x. Okay, try plugging in 1. Plugging in 1 to the top gives you sine of pi. Sine of pi is 0, and ln of 1 is also 0. So we once again have 0 over 0, which means we don't know what the answer is yet. We can't use any simplification or canceling, but we can use Lhopitals rule. Okay, so the derivative of the top, the derivative of sine is cosine. Keep the inside the same, and then multiply by the derivative of the inside, which is pi. That was chain rule. Okay, derivative of the bottom is 1 over x. Okay, now we try to plug in 1 into the equation. Cosine of pi is negative 1. So negative 1 times pi over 1. So the answer is negative pi. All right, let's do another example. Limit as x approaches 0 of sine of x minus x over x squared. Okay. If we try to plug in 0, we would get sine of 0, which is 0, minus 0. So 0 minus 0 is 0. And 0 squared is 0. So of course we have 0 over 0. Okay. So using Lhopitals rule, the derivative of the top is cosine of x minus 1 over 2x. Well, let's try to plug in 0 into this, see what we get. Cosine of 0 is 1, 1 minus 1 is 0, and the bottom 0. Oh no, we got 0 over 0 again. In a case where you have, you use Lhopitals rule and it's still 0 over 0, just do it another time, okay? So, use Lhopitals rule another time. Derivative of the top is negative sine of x. The derivative of the bottom is 2. And when you plug in 0, you get 0 over 2. So that's 0. So final answer is 0. So there may be some times where you have to use Lhopitals rule multiple times. And as long as you keep doing it and the equation's getting simpler and simpler, you're eventually going to get to something so simple that you just have an answer. There may be some times where you can arrange a type of problem where no matter how many times you take the derivative, maybe you're falling into a repeated pattern so that you're just running around in circles. Might have to look up and find a problem like that. I can't think of one off the top of my head. I just know that they exist. So sometimes when you have something that's running around in circles, you just have to take use of that to somehow figure out what the answer is. Anyway, so this is Lhopitals rule. Now, Lhopitals rule can apply to more than just the 0 over 0 case. It can also apply to infinity divided by infinity. Okay, let's do one example of that. So let's say we're doing a limit as x approaches infinity of e to the, let's do e to the x squared over x. Okay, so as x approaches infinity, this would approach e to a very large number, so e to the infinity would also go to infinity. And the bottom is going to a very large number, so we have infinity over infinity, which is indeterminate. And we can use Lhopitals rule. So really, let me just write this up here. Lhopitals rule is for these two cases, when you have either 0 over 0 or infinity over infinity. Okay, so applying Lhopitals rule, the derivative of the top would be e to the x squared times the derivative of the top, which is 2x. The derivative of the bottom is simply 1. Now, e to the infinity, that's going to infinity. And 2 times infinity, well, that's going to infinity. And a large number times another large number is definitely a large number. So the answer is infinity. Okay, so I think that's going to be it for today. But the next video is going to be exploring more indeterminate forms and showing how to solve those. It turns out that there are 7 different total indeterminate forms, and really, Lhopitals rule can be used to solve all 7 of these different indeterminate forms by first doing some sort of simplification first, eventually getting it to become a 0 over 0 or infinity over infinity, and then applying Lhopitals rule. Anyway, we'll explore that in the next video. Hope you all are having a good day. See y'all later. Bye-bye.